Good morning, Algebra 2 students. I hope that you had a fantastic weekend and that you're ready to go ahead and learn some more of this algebra. Right now we're going to take a look at rational exponents. And so we need to remember what exactly rational means. Some of you might remember the word rational as far as what a rational number might be. And in our thinking about what a rational number is, remember a rational number is just a fraction. Exponent, you remember, is the power, whatever number you are using to raise a number or a variable to that power. So we put a rational exponent, you're talking about an exponent that is written in the form of a fraction. That's the basic easiest way to put it. We're thinking about fractional exponents. So you need to know what a fractional exponent actually is, since some of you may be completely unfamiliar with that. A fractional exponent is really just another way of writing a rational expression. The denominator of the fraction in your rational exponent is the index in your radical expression. So our denominator is the index. So we'll start with that, with all of the 1 over any kind of number. So what that would mean is that the square root of 36, and you all know that the answer is 6, but if we want to put it in rational exponent form, would be the same as 1/36 to the 1/2 power. Because our hidden exponent here, our hidden number in our index is a 2. So that goes right over to the denominator. So another way of writing 36, the square root of 36, is 36 to the 1/2 power. Another way of writing the cube root of 8 is writing 8 to the 1/3 power. So anytime that you're having an index here, it can be rewritten in fractional form so that you can get your fractional power. Now, hopefully you're able to see that the 4th root of 32 would then be 32 to what power? 32 to the 1/4 power. So hopefully that's pretty easy for you to understand. So we're getting an idea of what these fractional or rational exponents are like. All right, don't forget to pause as needed so that you can take your time and write these things down. I do urge you to hang in and watch all the way to the end of the videos. Some of the video counts are showing that people are kind of watching just little bits of it. I know that you might be fast forwarding and doing all kinds of things with that, but just please hang in. I do have things that I'm interjecting throughout the lesson, so please make sure that you've watched the whole thing. All right, so you can go in the other direction also and taking your exponents or your rational exponents and changing them into radicals. So you can take this and rewrite it as the cube root of 125. And we've talked about what you can do with that. You can find the cube root of 125 by asking what number times itself gives you 125. So the answer to that would be 5. So if you take 125 to the 1/3 power, the answer to that is 5. I want to show you what that looks like on your calculator just right quick. Because what you can do, in addition to using that math button, what you can do is you can take a look at your fractional exponents. This might be helpful to you. So if I take 125 and I want to find the 3rd root of it, I can also take it to the 1/3 power. And that's another way of finding the cube root. All right, and that would work for some of your bigger roots as well, as long as you can rewrite them with fractional exponents. That might be helpful to you in other things. All right, so let's take a look at some of the other properties here. Okay, so another thing that you can do with these, if you have 7 to the 1/2 power, 7 to the 1/2, if we rewrite them as radicals, that means the square root of 7 times the square root of 7. Don't forget that a 2 is implied in our square roots. So square root 7 times square root 7 is really the square root of 7 times 7, or 49, which would give you an answer of 7. So using radical form can be used to help you by hand simplify some of these radical expressions. And that might be good for you down the road, especially on the SAT portion that doesn't allow calculators. You need to have all of your resources and to be able to do those things. So another thing that you can do, if you'll remember, one of our things about exponents, even when they're just normal exponents, is if you have like bases, you can solve by adding the exponents. So one thing you can do is rewrite as radicals, but another is to look for those like bases. So if I have 7 to the 1/2 power and 7 to the 1/2 power, and I add my exponents, because that's one of our special things that we can do with like bases, and it only works if you have like bases, in other words, the same number or the same variable. A half plus a half is 1. 7 to the first power is 7. This is just another way of solving when you've got these rational exponents to deal with. And another thing that you can do is looking for for like exponents. Well, wait a minute. What do you mean look for like exponents? Well, here's the thing. If I have 3 to the 1/2 power and I have 12 to the 1/2 power, that would be the same thing as saying square root of 3 times the square root of 12. And we already know that with radicals, if you have the same radical, you can bring them both under the same radical sign. Same thing works with the same exponents. So what I could do in this case, even though the bases aren't alike, since the exponents are alike, it's also okay to go ahead and multiply those bases. So 36 to the 1/2 power, that is square root of 36, which is something that can very easily be done mentally and get the answer of 6. All right, same thing here. Like exponents means that they're the same radicals, which means that you can put them under the same radical expression, so you can multiply these bases together. That should give you an 8. Some of you might be mentally getting ahead, which is fantastic. Please make sure you're thinking when you watch these. Think about it as in its radical form. It would be the cube root of 8. And you should be able to be at the point where that easily would pop into your head as being a 2. Okay, so just to backtrack just a little bit, you can either rewrite as radicals might help you, looking for like bases to add the exponents, or looking for like exponents in order to multiply the bases together. We had talked about the denominator as being the index, but some of you might have thought, well, wait a minute, and I can almost hear who it would be, would it say, well, what about if the numerator is not a 1? The numerator not being a 1 is actually when we can think about the powers. The numerator is the power and the denominator is the root. The numerator is the power, the denominator is the index. Okay, root or index, which type of square root, or what, not which type of square root, which type of radical it is. So we have a denominator of n, that gives us our index, and the numerator gives us our power. Now, notice I have it in two different forms. Both of them have the index as being the denominator, but this form has the power being under the radical, and this one has the power being outside the radical. Both of these mean the exact same thing, but depending on which problem you have, one or the other might be the easiest to work with for solving. just right here, I can very easily make this the index, make this the power, and rewrite like this. This is a great way to take a look at this one. It can't be simplified. We've got x to the third power. There are only 3 here. None come out. So we've got nothing that we could simplify there. I want to take a look at this one. Now, each one of these problems will lend itself to a different one of these forms, and you will learn just by experience which one is more convenient for a certain type of problem. So let's take a look at 8 to the 4/3 power. When you first evaluate these, take a look at your index and ask yourself if it's an easy problem to find that root of this number. If it is, you're going to want to do the method where you do the root first and then the power. So for example, this one, because finding the cube root of 8 is a pretty easy thing to do, we're going to do the root first and then take the power. So our cube root of 8 is 2, and 2 to the 4th power is 16. So our work comes out to be pretty nice by doing the root first here. On this particular problem, though, there's no easy answer to the cube root of 4. Think about that for a minute. 4 is 2 times 2. There's not a group of 3 to come out. So since there's no easy answer to that, for this particular power, it's easier to take the power first and then the root. So for this one, what I want to do is I want to do 4 squared first and then break it down and simplify so that I have all those 2's. A group of 3 2's means a 2 can come out, and you're left with 2 times the cube root of 2. So once again, depending on what problem it is, look at your denominator, figure out which root that is, which index it is. Ask yourself, is this an easy solve? If it's an easy solve, do the root first, then the power. If it isn't, then do the power first and then the root. Writing in radical form sometimes, especially if you've got this decimal, don't let that bother you too much. But if we're going to take this, you can either do it with the index first and then the power, or the power first, then the index. A couple of different ways of writing this one. This one, just make sure that your index is 7 and your power is 2. If you wanted, you could do the other form. Not really a big deal for this one. When you have a decimal, what you should do is rewrite it into its fractional form. Negative 3.5 is the same as negative half, so negative 7 halves. In that one, you can use the rules for negative exponents, even though it's a fraction. Negative exponents means that it's the same as 1 over that thing to a positive exponent. And then you can rewrite that in its radical form. And I have that as the square root of y to the 7th. Now, you can't have a radical in the denominator, but before we try and handle that, let's simplify square root of y to the 7th. If you remember from what we were talking about before, y to the 7th, if we're going to take the square root of y to the 7th, that's the same as, I'll do this the long way this time just to remind you, there's 7 y's. So there's 1, 2, 3 groups of 2. Or you can do the easier thing where you're taking 7 divided by 2, and here we have 3 with 1 remaining. So here's another way to go directly to y cubed square root of y. So once we've simplified that, then we can think about, okay, I still have a leftover radical in the denominator I want to get rid of. So I need to have a pair. I need to have another one to make an even pair. So I can take an extra square root y over square root y, which would give me the square root of y squared in the denominator, which gives me y to the 4th. And in the numerator, we have the square root of y. So that's a nice quick way of simplifying that. One more pair to take a look at here. If you're writing an exponential form and you have 2 different exponents to deal with, you have 2 different things that you need to write when you're putting it in exponential form. We know that our index is 2. This first part, this 3, is to the 1/2 power, and this x is to the 5/2 power. Over here we have 2 things. This 5 is originally to the 1st power, so the 5 would end up being to the 1/3 power, and the x would end up being to the 4/3 power, looking like this. 3 to the 1/2 power, x to the 5/2 power. Exponent over index. 5 to the 1/3 power, x to the 4/3 power. Exponent over index. Exponent over index. All right, so that's the end of it. Please make sure that you fill out the video evaluation form that I have a link on the web page about. This week I am going to start making that part of your assignments category for your grade. So please, please, please make sure that you are filling out every form and doing everything, watching every video. That's part of what we're doing now. We're getting in the swing of things, and I love you all, and I can't wait till we're standing in front of each other again. And enjoy your day today, and I will see you when I get that privilege again.